Hello everyone, this is a summary video on the lesson 7.1 Permutations and Combination. So you might have previously studied to find the number of possible combinations of a group of objects using something known as the tree diagrams. We'll shortly discuss it and then we'll learn fundamental counting principle in this lesson. So first of all, let us describe what is fundamental counting principle and then we'll compare it with the tree diagram. If there are n items and m1 ways to choose a first item, m2 ways to choose a second item after the first item has been chosen, and so on, then there are m1 multiplied with m2 multiplied with up to mn ways to choose n number of items. What does this mean? Let's try to explain with a given example. So the question says, to make a yogurt parfait, you choose one flavor of yogurt, one fruit topping, and one nut topping. How many parfait choices are there? So you are making a yogurt parfait, and you have the choice of choosing one flavor of yogurt, one fruit topping, and one nut topping for a parfait. So how many parfait choices are there for you? This is the list of materials you have. So you have 2 yogurt flavors, 5 fruit flavors, and 3 nuts. Generally speaking, we'll start if we use the tree diagrams. So we have 2 yogurt flavors which are plain and vanilla. So we have a plain yogurt flavor and vanilla yogurt flavor. Then from each of them I can add 5 fruit flavors: peaches, strawberries, bananas, raspberry and blueberry. Peaches, strawberry, bananas, raspberry and blueberries. Okay, I can do the same thing for this one as well. Right. Then I have a choice of adding one nut flavor out of 3, which are almonds, peanuts and walnuts. So each of them can be again given 3 more branches. So almond, peanut, walnut. Same thing for these. Okay. And the same thing I can do for this side as well. It takes a lot of space and time if I was to do it using the tree diagrams. But let's see how many possibilities or how many combinations did we get here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 for this and 15 for this. So 15 and 15. So a total of 30 parfait choices I will have. But this method is very long, time consuming, and complicated. It gets messy. So we use the fundamental counting principle in which we just multiply the number of choices I have for each item. So for yogurt, for the item yogurt, I have two choices, two flavors. So I'll take two. Multiplied with, for fruits, I have five choices. So I multiply with five. That's my second item. And for the nuts, I have three choices. So three, that's my item number three. This is my third item, nuts. What's the total I'm getting here? 2 multiply 5 multiply 3, I will get 30. So using the fundamental principle, fundamental counting principle, this method is just shortened to only this much. So I had n items. So my items were yogurt, fruits, and nuts. There were the three. I had three items, and I had m1 ways to choose yogurt. M1 here was 2. So I had two ways because I had two flavors. I had M2 ways to choose the fruits. So M2 here is 5 because I had 5 options for fruits, and let's say M3 ways for choosing the nuts, which is the number 3. I had 3 ways of choosing nuts because I had 3 options for nuts. So if I just multiply the options, I will get the total number of combinations I can get from this. So number of flavors times number of fruits times number of nuts equal number of choices, which is 30. Similarly, for this question, which is more related to real life situations, a password for a site consists of 4 digits followed by 2 letters. A password consists of 4 digits and then 2 letters. The letters A and Z are not used. So we skip letter A and Z. And each digit or letter may be used more than once. How many unique passwords are possible? So first of all, let's clear it out. We have to make a password which consists of 4 digits. That means numbers. So I'll just try to depict numbers using hash. So I will have 4 digits followed by 2 letters. So let's say the letters we're using alpha. These are just to show the symbol of digits and letters. Now, when I say digits, how many choices do I have? Or how many options do I have? So digits start from 0 till 9. So I have from 0 till 9. There are 10 digits. 10 digits. And they said here that I can use the same digit more than once. Means it can be repeated. So I have 10 options for the first one, 10 options for the second one, 10 options for the third one, and 10 options for the fourth one. For all the digits, I have 10 options each. When we come to letters, they said we are not allowed to use A and Z. A and Z are not used. So we have 26 letters normally, but since 2 of them are not being used, So I'll subtract that, and I have now 24 options. 24 options for letters. So this one I have 24 options, and this one I have 24 options. So using the fundamental counting principle, I just have to multiply the options with each other to get the final result, which is, let's erase this, 5,760,000 passwords are possible using the given methodology. This is a simple question. Just skip it. This one is also a good question. A password is 4 letters followed by 1 digit. So similar to the one we just did. So 4 letters. Letters will use alpha followed by 1 digit. Uppercase letters and lowercase letters can be used and are considered different. So if you use uppercase and lowercase, in this case, in this situation, they are considered different. How many passwords are possible? So if I say I have 26 uppercase, I have 26 uppercase letters and 26 lowercase letters. That means I have a total of 52 options for each letter in the password. I have 56 options for this because I have 26 uppercase options, 26 lowercase. And here also 56, here also 56, here also 56. The digit, as we know, we have from 0 to 9, which is 10 options. So to find the final answer, we just multiply the options with each other. Let me So it is 52 multiplied by 52 multiplied by 52 multiplied by 52 multiplied by 10, which is 73,116,160 passwords are possible using this method. Okay. Coming to the topic of permutation. Permutation is a selection of a group of objects in which order is important. This part is the main part. So permutation is selection of group of objects in which order is important. So order of the objects in the selection is important. What does it mean? Let's see. So when there is just one object, you have only one way of choosing it. But when there are two objects, you have two different ways of choosing. If you consider order, if you consider you have one way of choosing B and then comes A, the other way is A, then comes B. Similarly, if you have three objects, then you have from here, from this branching, we have C comes first, C comes middle, and then C comes last. And if you start by choosing A first and then B, Then again, you have 3 more choices here. So a total of 6 choices are available if you have 3 objects. Now, if I consider there is one way to arrange one item A. There are, for a second item B, it can be placed first or second, so there are 2 times 1 permutation. A third item C can be first, second, or third for each order above. So we have to consider this, and then we have to come to this. So there are 3 choices per condition. So 3 from here and then 3 from here. So a total of 6 choices. When you try to write it in as numbers, we get 1, then 2 multiply 1, then 3 multiply 2 multiply 1. And if we have 4 objects, it will be 4 multiply 3 multiply 2 multiply 1, and so on. So we can notice a pattern here. You can see that the number of permutation of 3 items is 3 multiply 2 multiply 1. If you extend this to n number of items, it becomes n multiply with n minus 1, that is a number lower than n, then n minus 2, then n minus 3, till 1. This expression is known as n factorial. This expression here is known as n factorial. Okay, so let's say if I was to say, and it is written like this, n factorial. If I have a number, let's say 6 factorial, I will write it as 6 multiply 5 multiply 4 multiply 3 multiply 2 multiply 1, so on for any given number. So whatever number we have here in the factorial, multiply all the natural numbers that comes after it. I mean, all the natural numbers that are lower than it. Let's not say after or before. The natural numbers lower than it, and this n, then n minus 1, n minus 2, n minus 3, and so on up till 1. So this is known as n factorial, and it can be written as this way. So the factorial of a number is the product of the natural numbers less than or equal to the number. Less than or equal to the number. So less than or equal, that means it includes the number as well. So 6 factorial includes 6, less than or equal to the number. Now 0 factorial is 1. 0 factorial, if you have, it is considered as 1. So where do we use permutations and combinations? Sometimes, where do we use permutations? Sometimes you may not want to order an entire set of items. Suppose that you want to select and order 3 people from a group of 7. So you just want to select 3 people out of a group of 7 people. One way to find the possible permutations is by using the fundamental counting principle that we just learned previously. You can use fundamental counting principle to find the number of possible combinations. You'll get first person, second person, and third person. So for the first person, you have 7 choices or 7 options. For the second person, you will have only 6 choices because you already selected the first person. And for the third person, you'll have 5 choices. Once you multiply them, you'll get the number of permutations, which is 210. This is using the fundamental counting principle. Then we can also do this by using the factorial method that we just learned. Another way to find the possible number of permutations is to use factorials. You can divide the total number of arrangements by the number of arrangements that are not used. Total number of arrangements means since there are 7 people, so the total number of arrangements would be 7 factorial. And the number of arrangements of people which are not used, since I'm choosing only 3, that means 4 of them are not being used. Okay, so the arrangement of 4 people would be 4 factorial. So it should be 7 factorial divided by 4 factorial. Arrangements of 7 is 7 factorial, arrangements of 4 is 4 factorial. So I can write 7 factorial as 7 multiply 6 multiply 5 up till 1. For 4 factorial also, same way. Then we can cancel the common, and just like we saw in fundamental counting principle, we will only be left with the other 3, which will give me 210 permutations. This can be generalized as a formula which is useful for large numbers of items. So the question is, why do we have permutations and formula if we can just use fundamental counting principle? So we use permutations when we have a large number of items to choose from a large number of objects. So let's say if I have hundreds 100 items and I have to choose 50 or 55, 57, some big numbers, we use the permutation formula rather than using the fundamental counting principle. It becomes lengthy. So let's generalize this thing into a formula, which is the number of permutations of 7 items that we just saw, taken 3 at a time, is, we write it as 7p3. So how many items are there? How many items we are choosing? So 7p3 equal 7 factorial divided by 7 minus 3 factorial, which is 7 factorial divided by 4 factorial. The general formula would be NPR equal n factorial divided by n minus r factorial. So this is the general formula and you have to memorize this. So here n is the total number of items, r is the number of items we are choosing out of n items. How many ways can a student government select a president, vice president, secretary, and a treasurer from a group of 6 people? So first of all, we need to know something about permutation, which we said in the beginning that permutation is used where order of objects is important. So in this question, the order of the objects is important, or order of the people you are choosing is important, because each of them that you are choosing have a particular designation. The first one, let's say, is president. The second one is vice president. The third one is secretary. And the fourth one is a treasurer. So because they have different designations and they are not all the same, the order here is important. So we are choosing 4 people out of 6 people, and we know that order is important. So we will use permutations. So will be 6p4, which is 6 factorial divided by 2 factorial, and the answer will be 360 permutations are possible. So there are 360 ways to select 4 people out of 6 people. One more question. How many ways can a stylist arrange 5 of 8 vases from left to right in a store display? So here, to identify that this question is a permutation question, why I'm stressing on this part, because the next topic is combinations, and in that we'll see that when order is not important, we use combinations. So when you are getting a random question, you need to identify whether for the given question order is important or not important. So that's why I'm explaining from the beginning whether order is important or not, how to understand it from the language used in a question. So a stylist is arranging 5 of 8 vases. So that means he is choosing 5 vases from 8. But to know that order is important here, the hint given is left to right. So he's arranging them from left to right. A direction is given. That means when he's starting to arrange, a particular direction has been mentioned. He's not just taking all of them together and then placing it on the shelf or somewhere. He's arranging them from left to right. And because of this, we know that it is a permutation question, since order is important here. We will use 8p5. So, which is 8 factorial divided by 3 factorial. And the answer is 6,720 permutations. So there are 6,720 ways that the vases can be arranged. We are choosing 5 vases out of 8. And it's a permutation question. This is very similar to the first one. Now, this again is a digit question. How many ways can a 2-digit number be formed by using only the digits 5 to 9, and by each digit being used only once? So each digit is being used only once. And since it is a number being formed using 2 digits, that means order is important. How do we know that? Just a simple example. The number 18 and the number 81 has the same digits, but because of the order, they are 2 different numbers. So we know that a two-digit number order is definitely important of the digits. So here they said using only the digits 5 to 9, and each digit can be used only once. That means they are not supposed to be repeated. So it's again a permutation question, since order is important, and we are choosing 2 digits out of 5 digits. So it will be 5p2 and they said that repetition is not allowed. So it's definitely a permutation. So two hints are given. One, that it's a 2-digit number, and repetitions of the same number is not allowed. So we are using 5p2. If they would have said that a repetition of the number was allowed, then we would have to use a different method. By fundamental counting principle, it would have been an easier method. Okay. So it is 5 multiply 4, which is 20. So there are 20 numbers that can be formed when you are choosing a 2-digit number by using the numbers from 5 to 9. Coming to the topic of combination, a combination is grouping of items in which order does not matter. So order does not matter here. There are generally fewer ways to select items when order does not matter. So if your order is not important, so you have fewer ways of selecting items. For example, there are 6 ways to order 3 items. So if you have 3 items, you have 6 ways to order them if the order is important. If the order is important, you have 6 ways, as we saw in permutation beginning, but they are all the same combination. They are all the same combination. That means you have only one combination. So 6 permutations, but only one combination. Since order is not important, you can arrange A, B, C in any way, and if it's considered same, then there is only one combination. But if you considered it as a permutation, there are 6 permutations. So this is the general difference between permutation and combination. To find the number of combinations, the formula for permutations can be just modified. This is the formula for permutation. We can use this and modify it. Because order does not matter, we divide the number of permutations by the number of ways to arrange the selected items. So we already have ways to arrange all items divided by ways to arrange items which are not selected. This is for permutation. Divide the same with ways to arrange selected items as well, because order is not important here. So this is the formula for combination. So there are the number of combinations of 7 items taken 3 at a time. So before we did 7 items with taken 3 at a time using permutation, but here it is combination with a 7 factorial divided by 7 minus 3 factorial, which is from the previous, and multiplied with also 3 factorial at the denominator. So the formula is changed. NCR is n factorial divided by r factorial multiplied with n minus r factorial. This is the formula for combination. When deciding whether to use permutations or combination, first decide whether order is important or not. Use a permutation if order matters, and use combination if the order does not matter. So there are 12 different colored cubes in a bag. How many ways can Randall draw a set of 4 cubes from the bag? So there are 12 cubes in a bag, different colored cubes in a bag. How many ways can Randall draw a set of 4 cubes from the bag? So he's just drawing 4 cubes. They did not say anything about he have to draw them in a particular order. So we can clearly see that order in this question is not important. So determine whether the problem represents a permutation or combination. The order does not matter. The cubes may be drawn in any order. So it is a combination question. So if it is combination question, use the formula for combination. N is 12, R is 4. So it is 12C4, which is 12 factorial divided by 4 factorial times 8 factorial. The answer is 412. 95 combinations. The swim team has 8 swimmers. 2 swimmers will be selected to swim in the first heat. How many ways can the swimmers be selected? So there are 8 swimmers and you just have to select 2 swimmers. So since both are just normal swimmers and you are selecting from 8 swimmers, there is nothing related to order here. So it is again a combination question. So just apply formula for combination 8C8. There might be some words or phrases they will give you to confuse you, like the first heat. This here has actually no meaning or relation to order. This is just in the first round. So this has nothing to do with order. Some people might get confused, just to check that out. So 8C2, which is 8 factorial divided by 2 factorial into 8 minus 2 factorial. The answer will be 28. So there are swimmers can be selected in 28 ways. So with this, the recording is done. The summary of the lesson has been done. Thank you for listening.